My name is Ramesh and I'm part of team Kung Fu Panda. So together with Vamsi, we have developed a course readiness survey tool, and what this whole project is hosted in GitHub, that is provided by Georgia Tech. And if you search for course readiness tool, you should be able to find it. This repository has been made public, so you're free to take a look at our source code and contribute. And to contribute, you might have to raise a pull request. Master branch is protected from direct pushes. So let me get into the motivation behind course readiness survey tool. So one of the main problems that we are solving here is most of the prerequisites provided for various courses, not just in OMSCS but also in other online courses. It is not very specific. It's too vague and it's very broad. In one of the courses, it states that calculus is a prerequisite, but what area in calculus and how much of that is not clearly specified. Now, I took one of those courses and I had to go through about 200 Khan Academy videos to refamiliarize myself with calculus. And in hindsight, after I took the course, I realized that all that was not needed, only an intuitive grasp of calculus concepts were needed. And I could have spent more time learning graph theory, which in that course was the prerequisite did not give much importance, but the course had a lot of graph related problems, and I had to in the middle of the course I had to do a lot of background reading on graph theory. So we want students to be successful, and we develop the course readiness tool so that a student is prepared completely. He knows exactly what to expect in a particular course and what are the areas of improvement. So existing solutions are between naive to not too sophisticated. Naive solution is basically a few bullet points and web in the course web page, and some slightly better solutions are online or offline quiz. For example, the OMSCS advanced operating system, they give you a PDF file and ask you to take that course in order to figure out if you're equipped to do you know the basic concepts of operating systems. So something of that sort. But what we want to do here is we want to automate it much further. We want to have a common repository of all the courses, and any new what we want to do is the course readiness tool will parse through the course contents and the quizzes and exercise problems pertaining to a particular course, and link it with all the other dependent concepts in its database, and it will based on that it will administer a quiz where based on an adaptive testing algorithm, where the next question is determined by the answer to the current question. I'll get into more detail when I start the demo. So let me get into the demo. So how we typically start. So you can start the tool. This tool, the course readiness survey tool, it uses a Python module called Flask to implement a REST server, and Flask also implements renders our HTML files dynamically for the web UI. So all you have to do is start this Python module using Python UI flask.py, and this will listen to localhost 5000. So and the very so how it works is typically at the end of the quiz you will get so this is the knowledge graph that has been generated based on all the courses that we have, all the course contents that we have. For example, what we do here is if you take a concept, say arithmetic mean. Now, arithmetic mean would depend on arithmetic. You compute arithmetic mean by taking all the samples. You compute the sum of all the samples and you divide it by the number of samples. So at a minimum, to compute an arithmetic mean, you would need to know addition, you would need to know division, and you would need to know counting of numbers. So we have in our course repository, we have some basic courses like Intro to Statistics, Pre-Calculus, and Basics. Basics is basically a catch-all for all the dependent concepts that are not covered in pre-calculus and statistics courses. So I'll show you one of the curated course contents. So so this is the curated course content for arithmetic mean. So we have a tag based format to describe each concept and provide a quiz related to that concept, and we provide what are the choices, various answer choices, and what is the level and things like that. So based on it, we also provide for this particular concept what are the other dependent concepts. So for example, for arithmetic mean, as I explained, you have dependencies on addition, division, and counting. And this particular this example is very basic, but you can always extrapolate it to other concepts like quantum computing or say machine learning, which is very relevant to OMSCS and which derives very heavily from statistics. So in this proof of concept, we wanted it to be very simple. So we focused mainly on math and statistics concepts. So what we do is the complete course library is passed by the course readiness survey tool, and it generates a graph in this manner. And based on the answers, if you answer it correctly, it would mark the node, the vertex as green, and if the answer is wrong, you would mark the tool would mark that particular vertex as red. And as you see in the summary, you would this gives a very good visual snapshot on what are the areas of improvement and what are the areas where a student already has some level of mastery. And as I mentioned, we use an adaptive testing algorithm. So what this adaptive testing algorithm does is it takes the graph and it uses depth first search to compute each critical path. Now here in this graph we see there are about 67 critical paths, and it starts from the very first path, and it starts from the lowest concept and the most basic concept, and it keeps going up in complexity. And each concept you can have levels such as easy, medium, or hard, and it keeps going. Each correct answer would increase the level, either the level or it would go to a slightly more complex concept. And the very first answer of the very first wrong answer that is encountered will trigger a change to the next critical path, and that's how we exhaust the whole graph. So for example, here we get this we get this question as soon as you launch localhost 5000, and we submit, and you get the next question, and so on. So I know the answer is to the power of 8, so I'm doing a deliberately wrong answer. So now this will start a new a new critical path and go on to the next basic concept of that particular critical path. And at the end of the quiz, it would generate this summary, and it would give you a feedback on what are the areas that needs improvement and what are the areas that a student already knows. And it also gives a summary on, okay, what was the question asked, what was the concept it was related to, provided response, and the correct answer. So here I know that I got the equations questions wrong and the imaginary number wrong. So equations, the answer was -1, but I had given -2. And with respect to imaginary numbers, the answer was -12, but I gave 7. So hope you like the demo, and you can try it out. So the VM where this particular this particular tool needs a lot of Python packages related to generating the graph, and based on your feedback from intermediate milestone 2, I've decided it's a better way to give you directly the OVA file which has everything, and all you need to do is import that particular OVA file in VirtualBox hypervisor, and just execute Python UI flash.py, and access the URL localhost 5000, and give it a try. So hope you like the demo, and looking forward to your feedback. Thank you.